Hi, I'm Tim Kelly, and today we're going to learn how to use MongoDB's time series collections in Java. We're going to build a fleet tracking application to track ships as they go across the world, and we're going to be taking advantage of MongoDB as a time series collection, as well as some features of GeoJSON data with MongoDB. So before we get started, there are a couple things you will need. First of all, you're going to need Java on the machine you'll be running this application. Next, you're going to need Maven, at least 3.9.6 for dependency management. And lastly, you're going to need a MongoDB Atlas account with a cluster created. So we're ready to connect. Once you have all that, we can get started. So in order to get started, you're going to make a new Maven application and you're going to head over to the POM where we're going to add our dependencies. Now this won't be a live code along video. What you can do if you want to code along is there's the written version of this tutorial with all the code snippets. You can copy and paste from there. It'll make your lives a lot easier. As well as that, we have the written tutorial with everything you need, all the information, and a GitHub repo with all the code as well as instructions to run. In this video, I'm going to be going through all the code. I'm going to be explaining how everything works together and how we're going to build it. So starting here in the dependencies, we're going to start with our MongoDB driver. So just version 5.2.0. As well as that, we're going to have Javalin, which we're going to be using for our API. So you can use Spring or whatever other API dependency you want to use. I just like Javalin. I find it quite lightweight. Next, we have Jackson just for data binding. So go between or bringing our stuff to JSON to BSON. We're using Jackson for data binding. And then lastly, we have just SLF4J. That's just our logger. Okay, so once you have all that, we're going to head to actually configuring our MongoDB. So now in our MongoDB config, we're going to specify our connection string, which you get from the Atlas UI by going to your cluster, you go connect. And if we go drivers, Java, you'll have your connection string here to copy and paste. You just need to include your password. So of course, if you're following along, this cluster won't exist when you're there, so you will need your own cluster. As well as that, we're going to specify our collection name, so we just have ship locations. Now there's a couple things here. So first, when we do our MongoDB get database, it will check to make sure that the database exists. And for here, we have our initialized database. And as well as that, it will make sure our time series collection exists if it doesn't already. So if we go into our initialized database, we just specify our server here. And as well as that, we pass in our connection string. And then we run with our, eventually at the end of this, we will just connect to our database. So for our create time series collection, what we need to do is we need to get all the collections from our database. Once we do that, we check the collection name versus the collection names that already exist. And if it doesn't exist, what we do here is we configure our options for our time series collection. So first of all, we have the timestamp. So this is our time field. It is the field we're using to, of course, measure the time, and it has to be of BSON data type. After that, we have our meta fields. So MongoDB allows you to hold a whole bunch of meta fields here. We just have boat ID. So the time series, what it does with the meta fields is it's used for internal storage optimization as well as query efficiency. It will automatically create compound indexes on the meta fields. So use them wisely, and with a well thought out planned document, this can really improve the performance of your application and really take advantage of what a time series collection offers. Lastly, we have our granularity. So when we create a time series collection, MongoDB automatically creates a system bucket system collection and groups the incoming time by the series data into buckets. By setting the granularity, we control how frequently data is bucketed based on the ingestion rate of your data. So you can use custom bucketing parameters like bucket max span seconds and bucket rounding seconds to specify the bucket boundaries and more accurately control how the time series data is bucketed. We're going to use seconds as this is simulated for our boats traveling over the sea, but what you want to do is you want to get the most similar to the actual time span for your data. So whether that's seconds, minutes, or hours, it doesn't have to match exactly, just as close as you can. So what we're going to do next is we're going to look at the models for our application. So create a model package, and in there, we're going to create 7 models. So first, what we're going to do is we're going to, in our model package, create the location class. The location class is nice and simple. It's just a double for our latitude and a double for our longitude. Because with our models, or with our boats and with our ports, we're going to be using GeoJSON with MongoDB, and we're going to show that off in an aggregation. What we want to do is we just want to nest the GeoJSON data alongside with our documents, and this will be reused throughout. So creating this location model is just to make our lives simpler later. Once we have that, we'll go to our port, and in the port, we're just going to have a name for the port. So whatever name that port is, the New York port, whichever, and then the location, which is just going to be the coordinates for the port. So the longitude and latitude. As well as that, we need all our getters and setters. And lastly, what we also need is a toDocuments function. So here what we do is we take in our port name, our location, and we're going to add that is of type point. So that's a GeoJSON feature. There's different ways to use GeoJSON for lines, for areas. What we're doing is we're just saying it's a point location, and then we're passing in the coordinates. So first we have our boat model here. So our boat model just has our _ID, which is the object ID used for storing our documents in our MongoDB database. Next we have our boat ID. What this is just an identifier for each boat, and it's stored as metadata along with our time data in our time series collection. Next we have our location. So this is the live location for the boat as it passes through the sea in our application. And we also have the destination location. So this will be the end port, or where we're calculating on our boat moving to. After that, we have our getters and setters, and we have a toDocument method. So this is just for converting our JSON to a document to be stored in our MongoDB database with the appropriate GeoJSON. And lastly, we have a move method. So what the move method does is it simulates the boat moving from the start port to the end port. It does this by just using the current latitude, the destination latitude, and then uses the Pythagorean theorem, nothing special, to calculate how best to get there. It simulates moving at 20 nautical miles per hour, which is roughly correct for freighter ships. And what it does is it then converts these 2 degrees to move at that latitude, longitude. Now, after all that, there is a bit more going on here. I commented all the steps. If you want to look at the code, feel free to check it. Lastly, what it will do is if the boat is close enough to the destination, it will just snap to that destination instead of calculating a step around that. So it's a bit of logic in our application, but it's just to make this a slightly more exciting simulation of time series data. After this, what we're going to look at is our last model, which is our boat request. So our boat request is just what we take in from the controller, and what it does is it provides the boat ID, so the boat name, so it could be boat 00X. And then it will have a start port, so New York, and destination port, another coastal city, let's think somewhere in Portugal. And what it will do is it will go from that start port to the end port. It will get the longitude and latitude for that. And then with our boat, it will pass that in so it can perform the simulation. So now that we have all our models, what we're going to look at next is our repository. So up next, what we have is our repository package we're going to have 3 repositories in it and implementations. So in this, first of all, we have our boat repository. It's just one method, void add boat, and it takes in a boat model. So if we look at the implementation for that, it's nice and simple. We have our MongoDB database, which we get from the config. And in here, what we're going to do is we're going to get our collection, and then we're going to add our boat, which we're going to cast to a document and insert that boat into our collection. So again, super simple, and we'll move on to the next. Okay, so up next we have our port repository. So in here, what we have is we have an add port, just a method for adding our ports, and then also getting our port by name. So what it does is it takes in our port object or our model, which we set up earlier, and it will use that port just to retrieve the port and the coordinates for that. So if we look at our implementation, so our add port is much the same as before. It has the port toDocument, which is inserted into our collection, and then the get port by name. So in our get port by name, what it does is, first of all, it will find the first port by that name in our database. It expects them all to be unique. So that is one consideration in this simple little application. And then what it will do is it will get the location. It will get the coordinates for that as well and pass it into a double. And then it will create a location out of this and return a port with the name of set port and the location just in our location model. Okay, and we're on to the last. So in here we have our time series repository. So this is just for interacting with the time series collection. I thought we'd separate it out as we have a little bit going on in here. So first of all, we have our void log boat location. Super simple, just takes in the boat ID and the location. I'll show you that. And next we're going to have an actual aggregation pipeline, which is calculate total distance traveled. So I'll show you what that looks like in a second, but be warned, it looks like a lot, but it really is super simple. So if we look at our implementation, we'll start at the very top here, where we have our log boat location. And in here, it just has the type point like we were doing earlier with our GeoJSON to tell it's of type point. And then we're going to take in the coordinates and pass in those coordinates as an array list, or as an array. And next, what we do is we log that entry with the timestamp of whatever the current time is. We're simulating seconds, which are sort of duplicating what the boat should be doing in an hour, but it works for this example, and with that location. Next, what we have is our calculate total distance. So, like I said earlier, what this is an aggregation pipeline. So it consists of 3 steps. First of all, we're going to set the window fields. So this is just for calculating the coordinates shifted from the previous position. Next, we're going to calculate the distance between the current and previous coordinates. And lastly, we're going to group by boat ID and calculate the total distance for each boat in our simulation. So boat 1 traveled this far, boat 2 traveled this far. So one thing you will notice is in our simulation, the boats will tend to travel a very similar distance because we're not adding crazy things like boats that move at different speeds or weather conditions to avoid or port closures. If you want to really expand out this application, absolutely something you can consider and make this aggregation result slightly more exciting. But yeah, for now, what it does is it basically uses some certain aggregation pipelines, the set window fields, which are specific to our time series collection. So as it did earlier, it uses the Pythagorean theorem, and it just finds the difference between the current and the previous latitude, the difference between the current and previous longitude, squares both differences and adds them together, and takes the square root of the sum to get the distance. And then, of course, lastly, just groups this to each boat. So now that we've looked at what's going on here, it's time to actually look at our services. So these will contain our business logic. So what we're going to start first with in our services is our boat service. So what this does is it just exists to create a boat. And it does this by taking in our port repository and our boat repository. In here, it will get the port by name for the start and end port. It will then create a boat, which we will need later when we're creating our simulation, but it will also add the boat to our database. So up next, what we have is our distance service. So our distance service just acts as an abstraction for the distance repository, or for the time series repository. It's super simple, and what we have here is just our calculate the total distance traveled, which we call later in the controller for an API endpoint. Up next, we have our port service. So in our port service, there's a little bit more going on, but what it does is it just initializes our ports. So I hard-coded this to save you passing these in through the API later, but we just have a method here to initialize ports. It takes in a couple of ports, such as New York, as well as that. It has the longitude and latitude for each of these. Now you'll notice that these longitude and latitudes tend to be in the city and not very much at the edge of the city or the coast where you'd expect a port to be. Port exact locations are surprisingly hard to find, but these will work for the simulation. Just expect it to traverse for land at the very beginning and very end of each simulation. As well as this, at the end of the list, what we do is we add each of these ports to our database, so it is stored in MongoDB. And lastly, what we have is our simulator. So in our simulation, what we do is we take in a list of boats, and in this we have to run our simulation, which passes all of the boats through a series of steps, basically from their start port to their end port. Now in this, you'll see we call for each boat, it will call that move method that we set up earlier, which uses that Pythagoras theorem, as well normalize the distance and uses degrees to travel over the sea between each location. And then for each of these, it will log it in the time series location, and it will just print it out to terminal just so you can see what's going on while it's going on. It will keep doing this while it has each boat, or has any boats, in the simulation, and once boats have all reached their destination, it will just let you know that, or it will let you know as each boat reaches its destination, but at the end it will conclude. Now, if a boat does reach its destination, it will remove it from the simulation, so you're not just watching a blank screen, but after all that, it will tell you everything's completed. So that's all we have in our service. So last thing to look at is our controller. So in our controller package, we have the ship tracker controller. Now in here, what we've done is using Javalin, we set up a couple of endpoints. So we have our ports/init. What this does is it calls that initialize ports method that you saw earlier. We also have our /boats. This is how we add boats to our database and to our simulation. What we also have is our simulate endpoint, which will run our simulation and will start logging our data in our database. And lastly, we have our /boats, /total distance. This will run that aggregation pipeline that we set up earlier and will get the distance traveled for all the boats. So if you want to have a look through these, again, all of this code is provided to you, but we have a little bit of printing out of the system. I know, probably shouldn't have this. And what we do have is a little bit of, or a couple of system prints. And this is just so you can follow along with the application, and it will just pass through some of that JSON verification we're receiving as our application runs. So again, check out this code. I'll have it all linked down below, but what we're going to do next is we're going to get to actually running our application. So in order to run the application, we have our ship tracker app, and then here we've created our Javalin app, which we're going to start at port 7070. We have our controller, and then we've given that controller, we've registered those routes with our Javalin app. Now let's get things running. So for our testing and for simulating our app, what we're going to do is we're going to use the commands that I pass along in the written description of this tutorial. Again, linked down below if you want to copy these as we go through. But first things first, we're going to need to compile our application and get it running. So if I copy this and pass it into our terminal, what we'll have is it should build. Love seeing the success. And as well as that, it will start running. So of course, I don't have my logger configured here, but you'll see here after that, what it does is it tells us it created our time series collection. Every other time we try to access it, it just tells it, or it tells us it already exists. Now up next, what we're going to do is we're going to open up another terminal. And in here, first things first, we're going to have our ports initialized. So if we run this, perfect, we have our ports initialized. And what we can actually do is we can check in our MongoDB database, which is currently empty. But if we refresh that, perfect. So we have our ship locations, which should be an empty collection, perfect, and as well as that, a time series collection. Now, after that, we also have our ports. And in here, yep, we have each of our ports with the name, the location, stored as GeoJSON, so type point and coordinates. Okay, perfect. So after that, what we're going to need to do is we're going to need to add a couple of boats. So if I have my first boat there, perfect. So just boat 1, and we'll get a boat 2. Perfect. Okay, so boat 2. Now we'll see for each of these. So for the first one, what we have is it's starting in Port Miami and going to Port Lisbon. So a nice long one there. And what it will do is it will tell us, okay, so we have our boat 1. It's going from this location, giving the longitude and latitude to the destination. Now, perfect. As well as that, we have the same for our second. Okay, so once we have those two boats, what we're going to do is we're just going to simulate it. So if we run this simulation here, and what we should see in our first terminal is perfect. Okay, so the simulation has started and it will just log each simulation step for us. So this will take some time as the boats go across the ocean, but each second basically counts for an hour, and I think it will take about 3 weeks in real time, so whatever that works, or 10 days in real time, so whatever that works out to be. But each of these will keep going until they've reached their destination, and then it will give us that message that it has reached the destination. Now what we can also do is we can check to see if our aggregation pipeline works. So if we go over to our local, and what we'll do here is we'll go to, actually I'll add another one here, and we'll go, okay, curl get total distance. And perfect, so we have the total distance traveled by each boat. You'll see very similar, just as the approximations as it goes from the steps to degrees, or as it goes from the actual distance to the degrees, and as it normalizes those, you'll see it slightly varies, but you shouldn't see too much variation between the two of these, just with how the logic is implemented. Of course, feel free to add features for boats that move faster, boats that slow down as time goes on. Of course, they build up debris on the bottom of the boat, so they should slow down as they go on. As well as that, as boats take on weight, they will move slower. So if you want to add all these, that could be interesting. So for now, we'll see the distance of each of these just should be quite similar. And if we go to our MongoDB database and we refresh this one more time, what we will do is we'll see our actual ship locations. So this is our time series collection, and we'll see here we have our boat 1 as it's moving through, and whenever our boat 2 starts, it should be there as well. But for each of these, we'll have our point coordinates, and perfect. So we'll have our coordinates array there. Now, if we want to look for our boat 2, what I can just do is I can just go boat and ID, and then how did I name this? I called it all caps boat and then 002. If we apply this, And perfect. So we see all our boat 2 documents there. So as it steps through, these ones should go up in time. And as well as that, the location will slightly shift. So perfect. If you found this tutorial useful, make sure to like and subscribe. Check out the MongoDB channel for more tutorials as well as live streams. If you want to learn more, you can also check out our Developer Center, where we have written tutorials for this and many other in Java and various programming languages. If you have any questions, leave a comment down below. As well as that, all of the links for everything you need will be in the description. Thank you.